Hi guys, my name is Vaishnavi. I'm studying in Sri Venkateshwara College of Engineering. Subject is Mathematics in CSC stream. Topic Difference between one-way and two-way ANOVA. Introduction to ANOVA. Analysis of variance. ANOVA is a statistical method used to compare means between two or more groups. It is particularly useful when you have a categorical independent variable and continuous dependent variable. ANOVA helps determine if there is a significant difference among the means of the groups being compared. One-way ANOVA. One-way ANOVA is used when you have one independent variable with three or more levels or groups. It compares the mean of these groups to determine if there is a significant difference between any of them. The null hypothesis in one-way ANOVA is that all group means are equal. One-way ANOVA. Hypothesis testing in ANOVA. Since ANOVA tests for difference between means for multiple groups or levels. For fourth, then H1 is that there is a difference somewhere between these group means. H1 equals mu1 not equals to mu2 not equals to mu3 not equals to mu4 etc. H0 equals mu1 equals mu2 equals mu3 equals mu4 etc. These hypotheses are called omnibus hypothesis and testers for these hypotheses omnibus testers. Two-way ANOVA. Two-way ANOVA is used when you have two independent variables, each with two or more groups and levels. It allows you to examine the interaction between these variables and their effects on the dependent variable. Two-way ANOVA not only tests for main effects on each independent variable but also checks for any interaction effect between them. The chart of the one-way ANOVA and two-way ANOVA. Difference between one-way and two-way ANOVA keyword. One-way ANOVA is used when comparing means across multiple groups for a single independent variable. Two-way ANOVA, on the other hand, is used when comparing means across multiple groups for two independent variables. The main difference between one-way and two-way ANOVA lies in the number of independent variables being considered. The chart one-way ANOVA and repeated measure one-way ANOVA variables used with one categorical predictor variable and one continuous response variable used with one categorical predictor variable and one continuous response variable. Subject. Each subject only appears in one group. Each subject appears in each group. One-way ANOVA. One-way ANOVA examines the variation between groups and within groups based on a single independent variable. It determines whether there are significant differences in means among the groups. One-way ANOVA requires the assumption of independence, normality, and equal variance in the population being compared. Two-way ANOVA. Two-way ANOVA allows for the stimulus examination of the effects of two independent variables on a dependent variable. It determines whether there are significant main effects for each independent variable and if there is an interaction effect between them. Two-way ANOVA requires the same assumption as one-way ANOVA, namely independence, normality, and equal variance. Two-way ANOVA variance. Two-way ANOVA is applied to a situation in which you have two independent nominal level variable and one interval or better independent variable. Each of the independent variable may have any number of levels or conditions. Example treatment 1, treatment 2, treatment 3, so on, no treatment. In a two-way ANOVA, you will obtain 3F ratios. One of these will tell you if your first independent variable has a significant main effect on the DV. A second will if your second independent variable has a significant main effect on the DV. The third will tell you if the interaction of the two independent variables has a significant effect on the DV. That is, if the impact on one fourth depends on the level of the other. Difference between one-way and two-way ANOVA. One-way ANOVA is used when we have one independent variable factor on one dependent variable, while two-way ANOVA is used when we have two independent variable and one dependent variable. One-way ANOVA also has to compare means across different groups, while two-way ANOVA allows us to examine the interaction between two independent variables on the dependent variable. One-way ANOVA provides information about the main effect of the dependent variable, while two-way ANOVA provides information about the main effect of both independent variable as well as their interaction. Application of one-way ANOVA in real life and in engineering. Real life one-way ANOVA can be used to compare the average income of people across different education levels such as high school, college, and post-graduation degrees. Engineering one-way ANOVA can be applied to analyze the impact of different manufacturing processes on the strength of a material, such as comparing the mean tensile strength of sample produced by different methods. Applications of two-way ANOVA in real life and in engineering. Real life two-way ANOVA can be used to examine the interaction between two factors, such as the effect of diet and exercise on weight loss and whether the impact of exercise differs depending on the type of diet. Engineering two-way ANOVA can be employed to assess the combined effect of temperature and pressure on the performance of a combustion engine, investigating if there is an interaction between these variables that affects the engine's efficiency. Difference between one-way and two-way ANOVA. One-way ANOVA is used when we have one independent variable and one dependent variable, while two-way ANOVA is used when we have two independent variable and one dependent variable. One-way ANOVA can only determine if there is a significant difference between the means of three or more groups, while two-way ANOVA can determine if there is a significant interaction between the two independent variables in addition to the main effect. One-way ANOVA uses a single F-test to determine significance, while two-way ANOVA uses multiple F-tests to analyze the main effect and interaction effect. Reality related problem of one-way ANOVA. Suppose we want to compare the average test scores of students for three different schools to see if there is a significant difference. We collect the test scores of randomly selected students for each school and perform a one-way ANOVA. The null hypothesis is that there is no significant difference in the mean test scores between the three schools. One-way ANOVA is applied to independent sample taken for three normal distributed population with equal variance. Which of the following is the null hypothesis for this procedure? A. mu1 plus mu2 plus mu3 equals 0. B. mu1 plus mu2 plus mu3 not equal to 0. C. mu1 equals mu2 equals mu3 equal to 0. D. mu1 equals mu2 equals mu3. 10th one. Consider the following patrol ANOVA table. Source of variation SS, DF, MS, F. Treatment error total 75, 25, 6.67, 60, 3.75, 135 and 19. The numerator and denominator degree of freedom for the F test identified by asterisks are 4 and 15, 3 and 16, 15 and 4, 16 and 3. Related problem of two-way ANOVA. Suppose we want to investigate the effect of temporary and humidity on the growth of plants. We set up an experiment where we vary temperature low, medium, high and humidity low, medium, high and measure the plant growth as the dependent variable. We perform a two-way Anova to analyze the main effect of temperature and humidity, as well as the interaction effect between them. The problem. Example of one-way and two-way Anova. In a psychological study, we want to examine the effect of different type of therapy independent variable on participants and exert level dependent variable. We use one-way ANOVA to compare the means of anesthetic level between three therapy groups. In our study, we want to investigate the effect of both therapy type and gender, two independent variables on participant and NXT level dependent variable. We employ two-way ANOVA to analyze the main effect of therapy type and gender as well as their interaction effect. Conclusion. One-way ANOVA is suitable we have only one independent variable and want to test for difference between multiple groups or conditions. Two-way ANOVA is appropriate when we have two independent variables and want to study for main effect and interaction effect. The choice between one-way ANOVA and two-way ANOVA depends on the research question and the number of independent variables involved. Thank you.